Day 25 in geometry, which is crazy. This is your last quiz. Last quiz ever, other than the final. And I'm excited to talk about finals week because guess what? If you're not a good test taker, there's actually a project option that we'll talk about. If you're an artistic person, I think you might like the project idea, and we'll talk about that here in a moment. Then here's a practice quiz right here for you. So I am just going to write on here that it is day 25. And this practice quiz will be kind of like your day 25 exit ticket. So it will be due on Friday, this Friday. And that is the 19th. So just something to keep in mind. And then I will title this as my answer guide. And we'll just do kind of a walkthrough of all the questions together today. Now, of course, if you want to do this at your own pace, you're welcome to work ahead. But I would like for us to just kind of have a good review of everything as a class in Unit 4. So on your first page of this practice quiz, there are 4 questions where you are finding area and circumference. And we talked a minute ago about how we want to make kind of a little guide of all the formulas we'll use because there's a lot of formulas in this unit. So what I'm going to do is on each page, I'm going to make a sticky note. And so I don't lose track, I'm going to write page 1. And each of you should have lots of sticky notes at your tables if you want to do the same. And we're going to write all the formulas we need. So for these questions, I need area formula, I need circumference formula, and I also need to know the difference between a radius and a diameter. So first, what's our area formula? Anybody remember? I make a little list. Yes, pi radius squared. And then circumference, we have 2 different options for a formula. What is one of those options? Circumference. Yes, 2 pi r. So these formulas are both using radius. Now, if I don't have a radius, let's say I have a diameter, what's another circumference formula? Using pi and diameter. Kind of. Radius is half of diameter. So I have radius times 2 in this formula. It's kind of a trick question because the circumference formula with diameter is just pi diameter. So these are your 2 options. Say, use either one. And of course, if you are worried you might forget what diameter versus radius is, I'm going to draw like a little picture down here of each. Which one is radius? Which one's diameter? Diameter is the full one. Yes. Good. Diameter is the full one. Radius is the half one. A good trick for remembering which is which. The diameter creates 2 capital D's with the circle. There's the D for diameter. And then radius, it's like a little lowercase r right there. So that's your difference. Now that we have our formulas, I'm going to keep this and kind of move it around the page as we go to each question. So for number one, I am finding the area and the circumference of this circle, and we are using our calculator's value for pi. So if this is something you think you might forget day of the quiz, it's not a bad idea to also make a note that to use pi, we hit the second button and the up arrow, and then we have, if it would focus, well, there is a pi on there. So I could write pi is second up. You may not need to write that note, but if you think it'll help, it's not a bad idea. So for number one, I am given a circle and a measure of 11 feet. Is that a radius or a diameter? That is a radius. So I know radius is 11 feet. And let's use that to find our area. So I am looking at my formula sheet. I see area is pi r squared. We just said r is 11. So let's do pi 11 squared. Pi 11 squared. So I'll type that in. Pi 11 squared. I'll hit enter. And I will get 380.1327111. And is this an exact answer or an approximate answer? Approximate, good. Because we're including pi in the calculation, and pi is not a number that can be put into a fraction. It's an irrational number, meaning it goes on forever. Those decimals are going to continue for infinity. This is going to be approximate because we'll round our answer. And you can choose to do 1 or 2 or even 3 decimal places. For this, I'm just going to use 1 decimal place. I will do 380.1. So 380.1. What would my units be? Feet squared. And because this is approximate, what do I need at the end? The squiggly. This is the tilde. That means approximately 380.1 feet. Now, of course, if you don't want to mess with pi at all, you'll never have to type it in your calculator if you just use the formula. Don't type in pi. Instead, write it next to your answer. That would give you the exact value. So I could just do 11 squared. Don't include pi. Oops. 11 squared. And that would give me 121 pi feet squared. So I'll just write that above it. I would accept either answer. I would say 121 pi feet squared. You do not have to find both. You can pick one or the other. I will accept either one. So that's my area, my 2 options for area. Now we're trying to find circumference. And we've been given 2 formulas, 2 pi r or pi d. And in number 1, we have r, we have a radius. So I'm going to use that first formula. C equals 2 pi r. So 2 pi 11. And I'm just going to type that in exactly this way, just 2 pi 11, nothing in between. Enter, and I get 69.115, and so on. And I will just write 69.1. Is this exact or approximate? Approximate. We used pi, so this is approximate because we have to round. So 69.1, what would my units be? Feet. And of course, what do we need to include at the end because it's approximate? Squiggly. Tilde. Tilde.
We didn't remember that considering how good a movie is.
I do love that movie.
I'm the only one that stared and made the object like cartoon.
Oh my gosh, I did the same. If I wanted an exact circumference, what would that be? Pause this. Okay, back to this. Does anybody know how to do the exact circumference for number one?
You have to know how to do that. Stupid.
It'd be really cool if you knew how. It'd be really cool. So like for example, with the area, all I did is I took the area formula and I typed in everything except pi. So I typed in 11 squared. So for circumference, if I typed everything except pi, what would I get? What'd you say? 22. And then instead of typing pi, you write it. So my circumference would be 22 pi feet. So if you do it that way, sometimes the exact can actually go a little quicker if you know how to do it. Because then you don't have to type pi in. All right, that's number one. Number two is the same type of question, just different numbers. So I have a circle and the measure I'm given is 13.2 feet. Is this a radius or a diameter? That is a diameter.
Radius is 6.6.
Ooh, okay. So the radius is 6.6. How did you get that? Okay, good. So if we don't have the radius, that's the first thing we have to find. Diameter is 13.2. So the radius is 13.2 divided by 2. And 13.2 divided by 2. You are correct. It will be 6.6. So we're going to use 6.6 for all of our calculations for area. So if I want to find area now, what am I going to type in? Pi. Radius is 6.6 squared. I'm going to type that in. Get my approximate area first. Okay. I want to make sure everybody's getting the same thing as me. Are you guys getting 136.8 and so on?
Yes.
Good. Okay, so let's put that here. Go ahead. 136.8. What are my units? Feet squared. And because this is approximate, what do I add at the end?
Tilde.
Tilde. Good. Okay. Now, before I spend more time giving the exact area and circumference for all of these, do any of you plan to use that exact? Okay. If not, we may save a little time and not do that for all of them. However, if any of you want to make sure that you've got the exact correct, I'm happy to go back and show you that. Okay, so there is my area. Now I've got two options for circumference. Does it matter which one we use? No, it doesn't matter as long as we're using the correct number. If I want to use 13.2, I've got to use the formula with diameter. If I use 6.6, we're going to use 2 pi r. I'm actually going to use the diameter one because it's a little less to type in. It's just pi times 13.2. pi 13.2. And let's see what that gives us. Pi 13.2. I got 41 point, that 6 makes the 4 round up to 5, so 41.5. And my units would be feet. And it's approximate, so tilde. Gotta have that little tilde at the end. Okay, so that is number 1 and 2. 3 and 4 are the exact same, but different numbers, of course. So for number 3, now I have 23.8 yards as my measurement. Is this a diameter or a radius? That's a diameter. Yes. So we just take that divided by 2. And then you're correct. The radius will be 11.9. Okay. And then we'll do the same thing. We'll use those formulas. Our area, pi, times, we just found the radius is 11.9. So we'll use that value, 11.9 squared. I'll just type that in. Pi 11.9 squared. And I got 444.8809 and so on. I will round that up to 444.9. What would my units be? Yes, yards squared. Tilde at the end. This is approximate. And circumference. Anytime they give us a diameter, I like to use the pi d, just because it's a little less to type. So I'm going to type pi, and will I still use 11.9 or 23.8? Yes, 23.8. And that will give us 74.769 and so on. I will round that up to 74.8. And again, circumference is just like perimeter. It's a length, so it's not squared. It'll just be yards. And it is approximate. Don't forget the tilde. If you don't have a tilde, you might lose a point. Don't forget it. Okay, and then last one, number 4. I have a radius this time. So we will use the area pi times radius 4.5 squared. Pi 4.5 squared. And we get 63 point, we'll round to 6. 63.6. And my units, yards squared. And is this it for area? Tilde. Put the tilde. Don't forget it. And now circumference. We said we have a radius. So I could just double that and use that same pi d that I like to use, but I could also not double it and just put a 2 in there, which doubles it for you actually. So we're going to double it regardless, but we can do it all in one step with that first formula. So I have 2 times pi times radius, which is 4.5. And that will give us 28.27 and so on. And that rounds to 28.3. What are my units? Yards. Tilde. Good. Good. Okay. This is the first page. I'll zoom out for just a moment just to kind of show the answers in case anybody missed them. Make sure you copy down not only the answers, but also the work so that you have a guide to look back at how to do these on the quiz. Any questions before we go to the second page? Any questions at all? Okay, let's go ahead then to page 2. And now I'm going to put that sticky note back on here for page 1. And we'll make a guide for page 2. So for page 2, now I have 2 questions for 5 and 6 where you are given an area and you are supposed to find the circumference. So we'll run through these problems here. So this is page 2. I'm actually going to write that this is just for number 5 and 6 because 7 and 8 are different. So if I am given an area and I want to find the circumference, we're going to need both of those formulas again. I'm going to need area formula, the pi r squared, and I also need circumference formula. And we're going to use 2 pi r for these problems. Now, to go from area to circumference, we need to solve for the radius first. So we are going to, step 1, set the area value, which in number 5 is 100 pi. 100 pi. We're going to set that equal to the area formula. So set area, wow, they are equal to pi r squared. Once we set that equation up, we solve for radius. And then we use radius to find circumference. So these are the 3 steps. So for number 1, it says set area equal to pi r squared. For number 5, my area is 100 pi. Make sure you include the pi. So I'm going to do that. 100 pi equals pi r squared. That's my equation for step 1. So I'll put a 1 next to it, just so that we can keep track of what we're doing here. Now, step 2, we want to solve for the radius. So if I'm trying to get r by itself, what is something I could do first to get us closer to that? Let's cancel out the pi's. We could divide by pi on both sides. So here's step 2, where we're starting to solve. And when I divide by pi on both sides, those just cancel, which is kind of nice. I don't have tissues, that's all I got. So whenever I bring down all my terms, what I'm left with is 100 equals radius squared. And I really didn't give you a lot of space for this. I apologize. And now that I have 100 equals radius squared, have I solved for radius? Am I done?
No.
What do I need to do now?
Square.
So I already have radius squared. What's the opposite of squared? Square root.
Yeah.
Good. I knew that's what you meant. So we're going to square root both sides. And that will give us r by itself equals, and what's the square root of 100? 10. Okay, so step 2 is done. I know that my radius is 10 inches. Now step 3, use radius to find circumference. And I wrote that circumference formula. We need 2 pi r. So let's do that. 2 pi r is 10. 2 pi 10. And I'm getting approximately 62.8. Are you guys getting the same number? 62.8. What are my units? Inches. Good catch. Yes, inches squared is only for area. Inches is for circumference. It's just the length. And this is approximate. Don't forget your tilde. So these are 3-step problems. Solve for radius, plug it in, find circumference. Do we have any questions about number 5 before we do number 6? Try to organize my work a little better on the next one. So number 6, now I have an area of 36 pi square feet squared. What equation could I set up so that I can solve for my radius?
36 pi. Oh. Sorry.
You're okay.
Pi radius squared.
Good. 36 pi equals pi radius squared. And we will go through the same process as the problem before. What should we do next? Divide by pi. Good. So that gives us 36 equals radius squared. And our last step is that square root. And what is our radius? Bless you. What's my radius? 6. Good. But I still need circumference. So
you're gonna put 2 pi 6.
good. 2 pi 6. And what does that give us? Get it.
37.69.
Perfect. 37.69 approximately. I'm going to round that to 37.7. And what would my units be? Feet. And what am I missing? Tilde. Feels like a silly detail, but it does matter. Does matter. If you don't want to do the tilde, you got to include pi in your answer. So, number 5 and 6, that's how we do it. Any questions about those two problems? All right, I'm going to scooch that up a little. Kind of fold that so it's out of the way. And now we'll look at 7 and 8. So for 7 and 8, now we are finding the measure of each either arc or central angle that is indicated. Assume that lines which appear to be diameters are actual diameters. So, meaning if there is a line that looks like it's going perfectly in a straight line, it is. So for this section, 7 and 8, there's a few things that I would recommend taking note of. And I'm going to make another sticky note here. Number 7 to 8 on page 2. These two angles? Yes, arcs. If you have the same number of arcs, it tells you that the angles are equal. Another thing to remember is a whole circle has how many degrees in it? 360 degrees. And half of a circle has 180. And of course, we know whenever that there are same number of arcs, it's equal. Okay. So really, those are kind of the three main little things to keep in mind here. I'll put that to the side. And let's look at number 7. So for number 7, we want to find the measure of the angle labeled WUX. So let's find that first.
First thing you want to do is 2 and then parentheses 14x minus 2 because there's 2 that.
Yes. Okay, so there is 14x minus 2 with a red arc on that angle. The other angle that is WUX that we want to find also has the same arc. So we can take that 14x minus 2 times 2 since there's 2 of them. We can also make note, if we want, we could just add them together. I'm going to go ahead and write that value 14x minus 2 over here so that I know this is part of the angle. And this is also, like I said, the angle that we're trying to find, WUX. So something I would recommend to you is before you start trying to solve, I would write that value somewhere so that you know this is what you need to plug into once you solve for x. So 14x minus 2. And something else that is good to note for both of these problems is that if we don't have just numbers without variables, step 1 is always going to be to solve for x. Once you've solved for x, then you can plug that in to find the missing angular arc. So first of all, I'm noticing in number 7, I don't see any diameters. So I'm not going to use 180 degrees. I do have those equal angles, which we already talked about. Is every angle labeled with something? Yeah, every single angle has a value. So if I have every angle labeled, what can I do to write an equation and solve for x?
14x minus 2
Mhm.
plus 16x plus 12 equals 360.
Yes, I'm going to draw this kind of arrow thing just to show why I'm putting a 2 here. There's two of these values. 2 times 14x minus 2. So that's both of these, plus the 16x plus 12 equals the whole circle, 360. So there's my equation. And we'll begin by distributing 2 times 14x. Yes, 28x. 2 times that minus 2, -4. I'll bring everything else down. Plus 16x plus 12 equals 360.
Be 44x.
Good. 28x plus 16x. You said that's 44? That is correct. 44x. And then,
But the positive 8.
yes, -4 plus 12 is positive 8. So plus 8 equals 360. Uh-huh.
So get it 352.
Oh my goodness. I always do that. I always write
Divide by 34.
divide by 44.
X equals 8.
Nice. X equals 8. So step 1 is done. We have our X value. Yes. So then once you do have X, this is where we go back up to the beginning. And this is where I always recommend to write the value that you need to plug into 14x minus 2. So I want to make sure everybody can still see my work. I'm going to plug in 8 for x. Let me see if I can find a way to show it all at once. There we go. So I will do 14 times, instead of x, 8 minus 2. Mm -hmm. 14 times 8 is 112, minus 2 is 110. So my answer would be angle WUX equals 110. What are my units? It's an angle. Degrees. Good. I know, it's easy to forget. 110 degrees. We don't normally say units when we're talking about degrees, so I probably threw you off. That's all right. 110 degrees. That is number 7. Now, number 8, I've got something being asked for. It's just got 2 letters. It's not an angle. What is that called? An arc. An arc. So we're just looking for the outer edge of the circle from F to B. And what value is labeled for arc FB? Good, 115 plus x. So I'm going to do that very first thing. I'm going to write that value up here, 115 plus x.
So we're x plus 75. Digging 1 at J. The J second right across is the exact.
So let's double check that. If they create a perfect x, like 2 diameters, then those opposite angles are equal. So I can check to see if it's a diameter by putting my ruler up to it. Just a little bit smaller. So I probably won't know what this measure is. I don't know what that is. I don't know what that is. This is where this little sticky note will come in handy. Do I have all my angles labeled? No. If I don't have all my angles labeled, we go to the next option. Do I have any diameters?
You have a perfect 180.
I do. What are the two end points of that? F and C. From F to C, there is a diameter. And if I cover up the rest of the circle, it makes it a little easier to tell that these two angles add up to 180. So let's mark that. F to C is 180. So what equation could I write to solve for x here?
115 plus x
Mm-hmm.
plus x plus 75.
Good. 115 plus x plus 75 equals 180. I'm running out of room. Okay. Same process as before. We'll combine any like terms. X and x will give me 2x. And then 115 plus 75, what will that give me? 190. Equals 180. Now, don't get nervous that you might get a negative answer, because when we subtract 190, that is going to go negative. That's okay, because this is just x. You cannot have a negative angle in a circle, but you can have a negative x value, because we're just going to plug that in later. So minus 190 on both sides. I'll bring down 2x equals, good, negative 10. Divide by 2.
X equals negative 5.
Good. X equals negative 5.
So what we did also be 150.
Yes, it will be. Whoops, gave you two with the same answer. Oh well. So what we do at the end is the same as number 7. We're going to go back to that value that I gave you, 115 plus x. Instead of x, let's plug in negative 5. And of course, whenever we put those together, 115 basically minus 5, that gives us FB, the arc FB equals 110 degrees. And that is number 8. That is number 8. And before we move to the next page, anyone have questions? Confusions? Okay. All right. Moving on. Last page. Page 3. Here's page 3. Number 9 and 10. We have 2 problems where we are finding the measures of line segments. So we got some formulas to write. Bless you. I am going to pull out my note page from that day. And this is one that you might not want on a sticky note. You may just want to have this note page out with you from day 23. Remember, we took notes on that Thursday.
A times B equals C times B.
Yeah. Yes. So for number 9, we have segments only inside the circle, which means we have interior segments, just like this. A times B equals C times D. So what I would do, if you don't want to have that paper, is I would make sure that if you're writing this formula on a sticky note, the hardest part about these problems is knowing what is A and B, what is C and D, because if you plug them in incorrectly, you will get an incorrect answer. So I'm just going to draw kind of a rough circle here and put like an X in the middle. Just remember that whatever you choose for A, B is on that same line. Keep following the line. Don't ever hop over to the other side of the V or underneath. It's the same line. So this is A and B. Then start over, C and D. And that formula, I'll write it here. A times B equals C times D. If it helps, I like to use colors and highlighters. So I know that my pink line, I could use that for A and B. Or I could say 4 is A, 3x plus 1 is B. Doesn't matter what order I put them in. And then I know my green line can be C and D. So there's a few different equations that I could write here. What is one idea for an equation I could set up?
3x plus 1 times 4
Yes, yes.
equals 2x plus 2.
Good. 3x plus 1 times 4. Hello.
Oh my gosh, you're so
I know. Little baby. So we got 3x plus 1 times 4 equals 2x plus 2 and 5 would be my C, D. So 2x plus 2 times 5. And now I've got my equation all set up. Distribute. Now, if it makes more sense to you to flip these at this step so that you have 4 on the outside of 3x plus 1, you can do that. But you can also distribute this way. So I am going to, first of all, remember that distributing is multiplication. Taking 4 times 3x plus 4 times 1. So 4 times 3x gives me 12x. 4 times 1 is 4. And same thing on the other side. 5 times 2x, 10x. 5 times 2, 10. Now the only tricky part about, I keep saying the only tricky part, these are all a little tricky. One of the tricky parts about this equation is we have variables on both sides. So whenever that happens, we can't just combine like terms by adding them together. What do I need to do differently here? How could I combine my x terms? Subtract. Yes, I'm going to choose the smaller one because I don't want a negative variable. So I'm going to do minus 10x to get rid of it there and minus 10x to bring it over here. 12x minus 10x is 2x. And I'll bring everything else down. Plus 4 equals 10. And we'll just solve the rest like normal. Minus 4 on each side. And I will get 2x equals 10 minus 4 is 6. And what is x 3.
Like the 30th on 2x plus 2.
Okay, so let's, yes, ND is what we need. And from N to D, yes, that is 2x plus 2. And that's what I should have done at the beginning. Let me make note of that here. ND equals 2x plus 2. And we just said x is 3. So we'll do 2 instead of x, 3 plus 2. That should give me 2 times 3 is 6 plus 2. So what is the measure of ND?
8.
8. And it doesn't give us units, so we don't have to include units. ND equals 8. Very nice. Okay. Move that sticky note to the side. Now for number 10, we no longer have the same type of problem. Still segments, but now we're going to use a different formula. Something to think about is because there's exterior segments, are there 4 segments where you have A, B, C, D, 3 segments where it's just A, B, C, or 2 segments? I'm looking and I see 4 distinct values: 8, 5x, 9, and 3x plus 1. So when that is the case, I am going to write that formula out. It's A times, let me get another sticky note here. A times A plus B equals C times C plus D. And same thing where A and B are on the same line, C and D are on the same line. So if I'm labeling my picture the same way as my sticky note, I'm going to let 8 be my A, 5x is my B, and then 9 will be my C, 3x plus 1 will be my D. So what equation will I write here?
8 means 8 plus 5x equals 9 parentheses 9 plus 3x plus 1.
Good. So 8 parentheses, 8 plus 5x, and then C, why did I write C? 9 parentheses, 9 plus 3x plus 1. 3x plus 1 is all of D. Yes. Then we will distribute on both sides. Another thing that we could do on the green side here is we could combine like terms inside the parentheses first. Completely optional. You'll get the same answer even if you distribute first. Let's go ahead and just distribute. So I know 8 and 8 went to the store and got a Nintendo 64. And then 8 times 5x.
40x.
40x. 9 and 9. 81. 9 and 3x. 27x, and then 9 and 1, 9. Good. Okay, now I'll zoom in on this equation.
So this is what I did. I just went ahead and combined 81 and 9.
Yes, I would do the same. That'll give us 27x plus 90, right? Perfect. I'll bring everything down. 64 plus 40x.
And I subtracted 27x from 40.
Okay, minus 27x. So we're combining our x's. Let's see, 40 minus 27, 13x equals, what comes down?
The 90 and 64.
Good, the 90, and don't forget the 64. 64 plus 13x.
So then we subtract 64. That gives you 13x equals 26.
Okay, 90 minus 6, 26.
Divide by 13. Yeah, x equals 2.
Good. So we're just following the normal process of solving an equation, and we get x equals, you said 2, 2. X equals 2.
Plug in to 3x plus 1.
Okay, so we have x equals 2. Now, something to be real careful about is we want to find SU. 3x plus 1 is ST. What's SU?
The full distance.
The
Oh,
full distance. So I need 3x plus 1 plus what? Plus 9. Add those together. This is all the way back to Unit 1, where we did the segment addition postulate. If I know that ST is 3x plus 1, and I know that TU is 9, then I know that SU is 3x plus 1 plus 9. Or I could just say everything that's on this line from STU I add together. So SU equals 3x plus 1 plus 9. And if I wanted to, I could go ahead and combine that 1 plus 9 and get SU equals 3x plus 10. And x is 2. So I'm going to plug in 2. 3 times 2 plus 10. 6 plus 10. Yes, that's 16. And that is your answer. All right. That is your practice quiz, other than the bonus question. I'll leave this up for a minute in case anybody is still copying down that work. And then we'll go through the bonus questions. So let me pause the video while y'all get caught up if anybody's still writing. Okay. All right. So if you are interested in the bonus question, we're going to look at that now. So we've been solving for central angles and arcs, but this is not a central angle. This is, we took a note on it at the beginning of this unit, but we never really did anything with it. This is an inscribed angle. Not equal. If it was a central angle, it would be equal. This is the one where we have, let me get a sticky note. I don't want to write on my workspace. For the bonus. Yes. Yes, it's double. So if this is my inscribed angle, meaning it goes all the way to the other side, not the middle. If this is A degrees, the outer arc is not also A like a central angle, it's 2A degrees. Now, we are trying to find ML, the arc, right here. There's no measure on it, but there is a measure here.
So you would put 2 parentheses 2x plus.
Yeah, absolutely. So if I know that this angle MNL, this 2x plus 16 is basically my A. I'm going to write that here. This is A. So ML must be 2 times A. And we said A is 2x plus 16. So now I have this measure. What is 2 times that? We'll distribute 2 times 2x, 4x, plus 16 plus 16. I don't know if that's 36. I think 32.
Oh,
Yeah, 32. That's okay. Okay, so here is my measure for ML. 4x plus 32. Now that I know all of that, can we use anything to solve for x here? Think about circles and arcs. How many degrees are in a circle? Think about what we have labeled.
isn't it 316?
Mm-hmm.
Okay. So it would be 8x plus 2 plus 4x plus 32 plus 9x plus 11 equals 1.
Yes, 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 yes. So if we have the measures of every arc in the circle, all the arcs add up to 360, just like the angles inside. So something we could do to just make sure of that, I see that from N to M, I have a measure 8x plus 2. From N to L, I have a measure 9x plus 11. And suddenly the whole circle has an outline. The whole circle is 360 degrees. So I'll make note of that on my sticky note. 360. I can just add these 3 arcs together and set it equal to 360 to solve for x. So let's do that. 8x plus 2 plus 4x plus 32 plus 9x plus 11 equals 360. And we'll just combine like terms. X, 8 plus 4 is 12 plus 9 should give me 21x. And then I'll combine my non-x's plus 2 plus 32 plus 11. And that gives me 45 equals 360. Once you know how to do it, it's not so bad. Then you just solve for x like normal. I'll subtract 45 from both sides. Bring down 21x equals, what is that, 315?
Yep.
Yes, good. And we'll take 315, divide it by 21.
X would equal 15.
X would equal 15. Perfect. So you can earn a bonus point for solving for x. You can earn another point for finding the measure of that arc in L. Now that I know x is 15, I'm just going to plug it in to 4x plus 32. Let's see. And 4 times 15 is 60. Plus 32 is 92 degrees. There's the answer. There it is. Okay. So that is your whole practice quiz, including the bonus. And the time is 10:32. We're a little bit past when I would normally give you a break. However, this is what we are doing today. We took the practice quiz. You're done. If any of you would like a blank copy of the practice quiz so that you can study this evening before our quiz tomorrow, just let me know. Or if you want to check in with me and make sure you've got everything caught up in here, things are turned in. If you have any questions, I am a resource here to help you, okay? So this is all we're doing today. If you have questions, feel free to stick around. If not, you all are free to go. The end. I'll put that on Classroom.